Alright, so let's just make a quick note about flight data analysis and logging. So what we're going to cover is, I assume that you're familiar with the PX4 logging framework. The integration layer that I have wrote, the PX4 Simulink input-output, has been just basically made part of that. I've used all of the existing tools and simply added all of these topics that we have talked about in the past. The Simulink inbound, outbound, all of those as part of the standard logging procedure. So if we were to run the Q-ground control with our firmware, we can go to Analyze Tools, to Log Download tab, refresh that. Well, right now it's not logging anything because it has never been armed, but basically all of this would get populated and logs will be produced. To ensure that that's actually happening is we need to go to the settings, type log, and if you go to SD card log profile, SD log profile, so you note how I already have changed that, but by default you're gonna have is this, which is one default set, general log analysis. There is nothing special about it. So for logging purposes, if you want to log the Simulink related topics, you have to enable that by setting this parameter to Simulink and guidance related topics all the way in the bottom. This will also include the default topics, although I have reduced a lot of the sampling rates there because, well, that data is essentially getting duplicated and we don't necessarily need that. Alright, so you have to modify this parameter. And then one that is actually very useful, that is not mandatory for anything to work, is SD log profile. SD log mode. So by default it is set to when arm until disarm, which again I keep it at default because I really like this behavior, meaning that you're not going to get any log files generated when you're setting idle. You can change that, or you can see other parameters too. Really just kept it at default, but just in case if you may have this set to disabled for whatever reason, this is one more option over here. But basically when the vehicle will be armed, it will create a new log file and start logging until it has been disarmed. Once it's disarmed, it saves, closes the file, saves it, and it's available on the SD card. It's actually available in the process of I guess logging, but it may not be 100% corruption free, and just probably it's not a good idea to access directly. That's pretty much it on the PX4 side of things. Just to test it, we can arm the vehicle. It has been armed, and then we can disarm it. This is simulator, by the way, but it doesn't matter. If we go to log download, you see there is one new log file available that has been created. It's very small because, I mean, it was a very brief episode, so I'm just gonna erase that. I would recommend erasing all of it before the new test flight date, so you start clean. Alright, so you can download that log into the folder using these tools that I just showed. Over here there's a download button. It will download a file with a .ulog extension. I already have some that we have recorded after our flights. So for example, and I'm using the PX4 Simulink input-output framework repository. So this repository over here with the RTV tilt wing example. Because this will have, well, unless told otherwise, but this has the saves for the flight data. So the flight data is part of this. So you can use this as an example as well. Alright, so let's plot one of the latest files in the saves, and by what we need to do is we better off just again running the project file with all of the toolboxes or any other things that have to be initialized. I'm using the VSDDL package. Boom, 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 boom. So what you need to do is use this open log tool. Really what it does, it just opens the .m file, the MATLAB script, and here I have copied some of the logs that I've plotted in the past. It doesn't matter where it comes from, really, it's just we're plotting the .ulg file. Alright, so if we step through we can just run this. And what we're going to see is a whole bunch of plots for all kinds of data that is part of this input-output framework. So for example, we see it can plot out of the box all of the rates. Like this is basically raw sensor data. Rates from the vehicle angular velocity message, sensor combined message for rates, acceleration, and so on. Just for your own reference, although that's not super needed. The other figure would be your distance sensor if you use that, which probably you are. We can cover that in a separate video, and so on and so forth. You can see the customization for that in this script. The whole logic behind this is I'm using the object-oriented, I guess, programming implementation of the MATLAB. So I'm just simply calling, instantiating the object with the file name, and that does all of the parsing automatically. That is part of it, and then I just need to call the dedicated functions or methods to plot data that I want to plot. This should be fairly self-explanatory in terms of what data I want to plot. Basically, the way it looks like, you go into your log plotter. There I wrote for all of this. This basically inherits the ulog parser, right? So the whole point here is, again, it's written for this input-output framework. When you instantiate it, it automatically saves the data internally, so you don't need to recall the ulog reader and read topics of the MATLAB as many times, like every single time. So this should be a little faster. And then it's written to parse all of the data of the Simulink inbound control and Simulink inbound according to the data structure. Like for example, your control vector. Again, if you ever changed anything, you would have to change this here as well, because it will no longer match. The order will no longer match. Same thing for all of the data, like the variables for the velocity position. All of the states that are being plotted. So you can take a look at that, add any more data that you would want. This is just more of an example of how I do that. Go back to the ulog plotter. Again, it inherits. It subclasses the parser as part of it, so it has access to all of its data. And then there are just like some quick function or methods, a method definition to plot some generic data for GPS, for example, altitude. That's what you see over here. All of that is written to where you see that you have different sources of the data. So distance sensor, well, that's not a good example. Let's go to, yes, for example, Simulink inbound position, or there is vehicle local position. So the plot is the exact same. Actually, the order of data is almost the same thing. Just need to grab a different entry of the topic. Actually, no, it's the same one. Never mind. But the key part is that the plots are all the same, so I'm reducing the number of plots that I have to write. But then I'm providing different data source. So again, this one comes from vehicle local position if you want to plot that. The other one comes from the Simulink inbound, but both are plotting position information. So this is just, again, a method that I prefer for all of the logging purposes in terms of parsing the data. And you can see all of the other examples. There's quite a bit of scripting and plotting related to all of that. There is also support for some time-based trimming. So for example, we just plotted our data. First of all, it's synchronized. So, I mean, all of the plots are not only plotted on the same x-axis, but also all of the data is synchronized, meaning that it starts from the same point. It's primarily because we use input-output framework. Everything is, again, as you recall in the previous videos I mentioned, it's published and subscribed using a single message. So synchronization is a lot simpler because it's already done as part of the framework. But for example, we wish to cut off the first 10 seconds of this plot. What we would do is we would, for example, use one of these lines, and I want to start at the second 10, right from the start of my log file. I'm just cutting off up until here. That's what I'm expecting to see the next time I'm rerunning this script. Whoops, we probably don't need all of that. Let's go over here. And yes, indeed, that has happened. That's basically, I mean, it's simple, just time-based trimming, which I find the most convenient of all. Notice that I keep the time stem global, so referencing multiple cropped figures is more intuitive. Like, your time is still relative to the start of the log file, so whenever you zoom into one region of it and you crop everything below or after, well, you still have the proper time step that you can match with the uncropped plot. Again, this is more of a preference. If you wish to change that, I think there is a parameter for that. Yes, so start at time 0. Hold on. Yes, I did add some of these parameters that can be changed. So for example, we can do log start at time at 0 set to true. Whoops. To true. So now we call everything again. I mean, pretty much all of these plots will start from t equal to 0, although, as you can notice, we have cropped out the first 10 seconds. Again, up to you. Things can be added and upgraded as you wish. This is pretty much the minimum example that I needed for all the purposes for all of our flight test purposes. Let me just revert this. All right. Same thing happens with the cropping data from the back of the plot, right? We can remove some seconds from the end of our log file in case we wish to remove some erroneous data due to the flight going not the way we expected in the first place and crashing the vehicle. This is pretty much it. This is more of a blueprint for all of your own purposes that you can take and continue implementing further topics. The actual place to look for in your source code upgrade package is if you go to your sources and then to your modules. As you all probably are aware of, there is this logger module, PX4 modules. So you can see the files that I have modified in the upgrade package. That's fairly straightforward, but basically you go to the logged topics CPP file, right? And you can browse all of the changes that I have made to enable this, which essentially all revolve around adding topics that did not exist. So I basically added this method, add sim topics, and then it contains all of the topics that I wish to log. specifically the Simulink related ones on top of the standard topics, with some of those being disabled just because we don't really use those, and I needed to save some CPU. Actually, this is important if you were to go and modify these things, thinking that, hey, we can start logging all the crazy stuff that we can possibly think about. Do not overstress this, because your PixHawk will start breaking out and basically have some, well, I don't know, CPU hiccups. I mean, basically you'll see not a stable update rate, but it will eventually start freezing for like a brief millisecond or a few. It will impact your flight performance significantly, but you won't really realize that that's what's causing it. Because writing a lot of data very fast, even on the SD card, is quite demanding. But yes, this is basically where you should look for anything that is related to flight log modification.